Yeah, sure. Co-primes are nothing but numbers which doesn't have any common factors. Those numbers are called co-primes. For example, um, you can take a minute. So 21 and 29 are co-primes, and any two numbers which doesn't have a common factor is called the co-primes. So we'll start with today's topics. We had covered till 4 yesterday, so today we'll start with 5. So a number is said to be divisible by 5 if the number ends with 0 or 5. For example, any number, you can call this ABCD, where ABCD are digits, and if the last digit is 5 or 0, this number would be divisible by 5. For example, 15, 25, 355, all these numbers are divisible by 5. 370, all these numbers are divisible by 5. What about the rule for 6? Any number is divisible by 6 if it is divisible by both 2 and 3. If the number is divisible by both 2 and 3, then it is divisible by 6. So we had seen earlier the rules for both the 2 and 3. The rules for a number to be divisible by 2 is that the unit's digit should have 0, 2, 4, 6 and 8. If the unit's place has any of these digits, it will be divisible by 2, and if the sum of the digits is divisible by 3, then it is divisible by 3. So if both these conditions satisfy for the 2 and for the 3, then the number is divisible by 6. For example, you take 12. 12 is divisible by 2 because the unit's place is, there is 2 here, and it's also divisible by 3 because the sum of the digits, that is 1 plus 2, that is 3, is divisible by 3. So this number 12 is divisible both by 2 and by 3, hence it is divisible by 6. I hope this is clear. We can take another example like this. This is divisible by 2, and 8 plus 4 is 12. 12 is divisible by 3. So this number is both divisible by 2 and 3, hence it's divisible by 6. Then the next common digits they ask is divisibility by 8. If the integer is divisible by, if the number or integer is divisible by 2 3 times, it is divisible by 2 3 times, or if the last 3 digits is divisible by 8. So either the number should be divisible by 2 3 times, or the last 3 digits, for example 6 8 7 8 1 6. So here the last 3 digits is divisible by 8. So this is divisible by 8. It's a whole number. So 68,000, 6,87,816. So this is the rule for 8. Then coming on to 9. So if a number, so you don't have to worry about divisibility of 7. 7 is not asked much. These are the, I'm covering just the common things that are frequently asked. I mean, if you want, you can take the divisibility of 7, but it's rather complicated. You can write down the rules for 7 also. So let me cover 9 and then I'll cover 7. So for the 9, if the sum of the digits is divisible by 9, then the number is divisible by 9. Number is divisible by 9. For example, 27, 2 plus 7 is 9. So this 27 number is divisible by 9. So you can take a random, I mean any number, for example 9, 7, 3, 2, 1. And if you want to check whether this number is divisible by 9, you have to add the whole digits and see whether the number is divisible by 9. Or what you can do is you can just eliminate 9 plus 7, you can add everything here and see if the final result is 9 or not. Or what you can do is first, you know this, there is 9, so remove this. 7 and 2 is 9, so then the remaining part is 3 and 1. So 3 plus 1 is 4. So the remainder would be 4 here when this number is divisible by 9. So this number is clearly not divisible by 9. So take down the rules for 7. A number is divisible by 7 if you take the last, I'll just write down the rule here for 7. Take the last digit, double it, and subtract it from the rest of the number. The rest of the number. The answer is divisible by 7. The answer is divisible by 7, including 0. Then the number is divisible by 7. Number is divisible by 7. So for example, we'll take the example here. Let's take the numbers 7, 84. So if you want to check whether this number is divisible by 7, what we have to do is we have to take the last digit, that is 4. We have to double it, so 4 2s is 8. And if and you have to subtract it from the rest of the number. So again, take the last digit, double it, and subtract it from the rest of the number. 78 minus 7, 78 minus 8 is 70. This number is divisible by 7. Hence, this number is divisible by 7. After this, we have 11, 10 and 11. Just erase this. Next number is 10. We had covered 9. So next number is 10. 10 is easy. If the last digit or the units digit is 0, if the units digit is 0, then it is divisible by 10. So if for 10 it's easy. If the last digit is divisible by 10, then the number is divisible by 10. For 11, for example, 20, 30, 40, whenever you have the last digit as 0, it is divisible by 10. You'll see 11. If the difference between the sum of the digits in odd place and even place is 0 or a multiple of 11 or a multiple of 11. So we'll take an example here. Uh, 121, any number. Let's take this as 7, 8, 6, 5, 3. So what you have to do is to check the divisibility, whether this number is divisible by 11 or not. What we have to do is we have to take the sum of the even odd digits and then the even digits. So this is, or you can do is you can take this alternate numbers and sum it. 7 plus 6 plus 3 is 10 plus 6 is 16. 8 plus 5 is 13. 16 minus 13 is 3. So this number is not divisible by 11. So this whole number is not divisible by 11. I hope this is clear. And regarding example for 7. So let's take any number. Let's take 798. So you have to take the last digit 8 and multiply it by 2. It is 16. Like you have to take this last digit and multiply it by 2. That is 16. And then the remaining number is 79. 79 minus 16 is 63. If this number is divisible by 7, then the whole number 798 is divisible by 7. 63 is divisible by 7, so 798 is divisible by 7. you can take 855. So you can multiply this by 10, I mean 2. This will be 5 into 2, 10. 85 minus 10, 75. 75 is not divisible by 7. So this 855 is not divisible by 7. I hope this is clear. Okay. So if there is any doubt till now, you can ask, or else we'll move to the next part, cyclicity. And before moving to the cyclicity, I just wanted to cover some rules of this divisibility. Multiples. Is there any doubt till now? I mean, if you have any doubt, please ask. Can we again apply the divisibility? I mean, Prajwal, what is the doubt? To check whether this number, any number is divisible by 7 or not. And you can take any number here, like 55, 32. So if you want to check whether this number is divisible by 7, we have to multiply the unit last digit here by 2. You have to double it. This would be 4, 2 2s are 4, and the remaining number is 53. 53 minus 4, this is 49. So 49 is divisible by 7, hence this number is divisible by 7. 532 is divisible by 7. I hope this is clear, Prajwal. If you have any doubt, you can please ask. Yeah, you can continue with that. I mean, if, for example, in this 49, at least we know 49 is a multiple of 7. So if it's some 5-digit number, like if some, this is like 8, 7, 4, 5, 6, 7. It's like, it is 8,74,567. I mean, you have to again do the same thing here. Until I mean, when you realize that this is a multiple of 7, you can stop. So see, we tried to find out whether 532 is divisible by 7. Right, we use this thing. Now we want to find out whether 49 is divisible by 7. And again, these things can be done here. And once we know, at least we know directly that 49 is a multiple of 7. So we can directly see that this is a multiple of 7. And the properties of these multiples are, for example, if you're adding multiple of a number, plus multiple, for example, if I'm adding multiple of 3 plus a multiple of 3, the result would be a multiple of 3. I hope this is clear. I mean, this property. If you're adding or subtracting any multiple of a particular number, the final result would also be a multiple of that number. And if you're multiplying a multiple of a number into a multiple of a number, any number, for example, let this be multiple of 8 and multiple of 6, then the resultant would be a multiple of 8 and 6, and also 8 into 6. Is there any doubt till now? Okay, next concept is the cyclicity. What is cyclicity? Cyclicity is, for example, there are questions where they ask you to find the units digits of a number. For example, they may say 3 raised to 5 or 3 raised to 2000. What is the units digit of this number? So to calculate, to find the answers for these questions, so we use cyclicity. So what is cyclicity? There is a property, in these numbers from 0 to 9, these digits, which is in the units place. These numbers, when you raise to certain powers, after certain powers, the units digits repeats. For example, let's take 3. So 3 raised to 1 is 3. 3 raised to 2 is 9. 3 raised to 3 is 27. And 27 into 3 raised to 4 is equal to 81. And after this, if you go again, 3 raised to 5, this would be again into 3, that is 243. And if you multiply this again, it will be 729. So this unit digit here, 3971. Again, this will be 3971. So the unit digits will repeat when the power of this 3 increases. So the pattern for 3 is 3971. So this again 3971. If you see 3 raised to 7, if you again multiply this 3 raised to 7, this will be equal to 2187. So again 3971. So this things repeat. This is called the cyclicity. For example, the cyclicity of 3 is 4. So it repeats after 4. So what we do is to calculate the unit digits of this place, of this number. So we divide this 2000 divided by the cyclicity. For example, if I divide this by 4, the remainder would be 0. So if the remainder is 0, that means you know that this number is a multiple of 4. And when the multiple of 4 here, 3 raised to 4 is, the unit digit will be 1. So 3 to the power of 2000's units digit will be 1. I hope this is clear. So we'll like this, we'll cover each digits from 0 to 9. If this is clear, please let me know. If you have any doubt for this, at least for this explanation for 3. Okay. See, what happens is, whenever you multiply certain numbers, at the end, the units place, numbers tend to repeat after a certain pattern. For example, I have taken the example of 3 here. For 3, for example, 3 raised to 1 is 3, 3 raised to 2 is 9, 3 raised to 3 is 27, 3 raised to 4 is 81. After this, if I take 3 raised to 5, I would get 243. So this number 3 is same as this 3. And then 3 raised to 6 is 729. The units place digit is 9. Again, this pattern is repeating, 3971. 3971 will keep repeating. So again, 3 raised to 6 is 3 raised to 7 is 2187. So 3971. And then 3 raised to 8 to calculate this. 187 into 3. This would be 6561. Again, this is 1. So 3971. So this numbers repeat. There is a pattern here. So after every 4 powers, like 3 raised to 1, 2, 3, and 4, it starts repeating again. So for example, if you want to calculate what is the unit digits of the number 3 raised to 2000, you have to divide this, you know the cyclicity as 4. You divide it by 2000, the remainder would be 0. The remainder is 0. Then the cyclicity here would be 1. I hope you understood this. If this is 3 raised to 2001, the unit digits of this number would be 3. So like this, we have cyclicities for various numbers. I'll just make a list of it. Please note it down. We'll go one by one. For 0, the cyclicity is 1, and only the number 0 repeats in the unit digits. For 1, cyclicity is 1 again. So 1 into any number, like for example 1 raised to 1, 1 raised to 3, 1 raised to 4, but always the unit digits will always be 1. For 2, the cyclicity is 4. The patterns that repeat is 2, 4, 8, and 6. I'll just show you the example here. 2 raised to 1 is equal to 2. 2 raised to 2 is equal to 4. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5, 32. So again, this is 2, 4, 8, 6. This repeats. 2, 4, 8, 6 repeats again. 2 raised to 6 should be 64. Again 2, 4, 8, 6 will repeat. So the cyclicity of 2 is 4, and the repeating digits are, this pattern is 2, 4, 8, 6. And for the digit 3, cyclicity is 4. The pattern is 3, 9, 7, 1. Just we have just seen it here. 3, 9, 7, 1, 3, 9, 7, 1, and it keeps repeating again and again. And for the digit 4, the cyclicity is 2. The repeating digits are 4 and 6. So you can see it here. 4 raised to 1 is 4. 4 square is 16. 4 cube is 64. And 4 raised to 4 is 256. Again 4, 6, 4, 6. It starts repeating again after every 2 numbers. So 4 is, cyclicity is 2, and the patterns is 4, 6. And 5, cyclicity is 1, it is 5. The unit digits doesn't change. For example, 5 raised to 1 is 5. 5 square is 25. 5 cube is 125. So every time the digit is the same. So cyclicity is 1. And the digits that is repeating is 5. For 6, the cyclicity is 1, and the digits that is repeating is 6. And for 7, the cyclicity is 4. The digits that are repeating is 7, 9, 3, 7, 9, 3, and 1. So you can just see it here. Let me just erase this thing. Seven to the power of 1 is 7. 7 square is 49. I'm sorry. 7 square is 49. 7 cube is 343. 7 raised to 4 is 2401. And 7 raised to 5 is 16807. This number 7931 will repeat again, 7931. So the pattern is 7931 and the cyclicity is 4. And for the digit 8, the cyclicity is 4. And the numbers pattern is 8, 4, 2, and 6. So 8, 4, 2, and 6. If you want, I'll just show you again. 8 raised to 1 is 8. 8 square is 64. 8 cube is 512. 8 raised to 4 is 2048. 8 raised to 5 is 10240. So 8 raised to 4 is 4096. 8 raised to 4 is 4096. 8 raised to 5 is 32768. Again, this pattern is repeating. 8426, 8426. It will repeat. The digits are 8426. For 9, cyclicity is 2. The digits are 9 and 1. So it always repeats here. For example, 9 raised to 1 is 9. 9 square is 83. 1 into 9, 729. Again, this number 9191 repeats here. The cyclicity of 9 is 2. So these are the cyclicities of the number, and when we see the questions, we'll use this data to find out the unit digits of that number. I hope this is clear till now. Please note down these things. The cyclicity of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. See, Ilkar, we'll keep this video public till 10:30. So you can again refer this video again. So if you have any doubts, please let me know. Till here. Are there any doubts until now? Things that we have covered. See, for example, now let's say they are asking 3 raised to 2000, and you know the cyclicity of 3 is 4. So you have to divide this number, the power divided by 4, 2000 by 4, and this number is divisible by 4. So the remainder would be 0. That means the power is multiple of 4. So whenever there is a multiple of 4, the power of power of the 3 is a multiple of 4. The unit digits will be 1. So 3 raised to 4 is 81, and 3 raised to 8 is 6561. This 1 is repeating again. So if the power is a multiple of 4, then this would be 1. If when you divide that number by 4 and if you get a remainder 1, then that would be the unit digit would be 3. So for 3, for example, here, so you can say if the remainder is 0, the unit digit will be 1. The remainder is 1, the unit digit will be 3. If the remainder is 2, the unit digit will be 9. If the remainder is 3, the unit digit will be 7. I hope you understood this. 3971. The same is with even this number. Like if I take 7 raised to 2000, so if you take, for example, if I take 7 raised to 2000, if I have to calculate the unit digits, so I would, so the cyclicity of 7 is 4. Okay. So I'll divide the 2000 by 4, the remainder would be 0. The remainder, when I divide this by 4, would be 0. So again, if it is divided by, if it is the remainder is 0, the unit digit should be here, the last one would be 1. So for 7, the remainder is 0, the unit digit will be 1. If the remainder is 1, the unit digit will be 7. Remainder is 2, the unit digit will be 9. If remainder is 3, the unit digit will be 3. And this would repeat again. For example, let's take some simple problem here. 7 raised to 41. 7 raised to 41 would be 7 raised to 40. 40 would be 41 divided by 4. The remainder would be 1 because 4 ones are 4 tens are 40. 1 is remainder. So when 1 is the remainder, the unit digit will be 7. I hope this is clear. Because 7 raised to 1, you can just check 7 raised to 1 is 7. The unit digit will be 7. And if the remainder is 2, for example, in this case, instead of 7 raised to 41, it is 7 raised to 42. When you divide this 42 by 4, the remainder would be 2. So your units digit would be 7 raised to 42, so units digit would be 9 because it is 2. And you get the remainder 2, the unit digit will be 9. So when you solve these questions, you would understand this. And if you know the concept here, that is more than enough for the current stage. Once we start solving problems, you'll understand. And the clarity will be more. If you have any doubts, I mean, Panther and LKR, if you have any doubts, please ask. And what is not clear? Suhas, is this, I mean, did you understand this? What about others? Okay. Sure. If things are clear, if you have any doubts, please ask. I mean, till now, whatever I've covered, if you have any doubts, you can ask. We'll move to the questions. So take 2 minutes to solve these questions. I'll just start the timer. So take 2 minutes to solve these questions. Please post your answers, and people who have already solved and not yet posted your answers in the chat section, please post it. There are around 5 responses till now, and most of them are for option B, that is 24. So we'll see what they're asking. They're saying that a gardener has 1,000 plants and he wants to plant them in such a way that the number of rows and the number of columns and number of columns remains the same. What is the minimum number of plants that he needs more for this purpose? So there are 1,000 plants, and they're saying that he wants to plant it in a row, 1, 2, 3, like this. But they're saying that the number of rows and the number of columns remain the same. If the number of rows and number of columns, like he has to plant it like this. So they want the number of rows. For example, if the number of columns is 4, they want the number of rows also to be 4. So 3, 4, and 1, 2, 3, 4. So like this, if he has to plant the gardener has to plant the plants, then they are asking if there are 1,000 plants, how many more plants does he require to complete the pattern like this? So for example, if there are n columns and n rows, because they're saying there are a number of rows and number of columns should be if there are n column and n row, the total plants would be n square. But here, since 1,000 is not a perfect square, 1,000 is not a perfect square. If we know that if we take 30 into 30 gives us 900. So 1,000 is not a perfect square. The nearest number to 1,000 would be 31 into 31 would be 961. And 32 into 32 would give 1024. So if we have 32 columns by 32 columns, then we would have 1,024 plants. And we just have 1,000 plants here. And they're asking what is the minimum number of plants that he needs more for this purpose. The minimum number is the next number, which is a perfect square after 1,000. The next perfect square after 1,000 is 1,024. The minimum is 24 plants he needs to make this a perfect square. The correct answer is option B, 24. This is the minimum because after this again, if you make 33 into 33, this will be 1089. 33 into 33, 1089. Again, this 1089 is a perfect square, but they're asking the minimum plants that he needs, that is 24. And if you give 89 plants also, his work would be done, but they're asking the minimum number of plants that he needs to have equal number of rows and equal number of columns. Are things clear? If there is any doubt, please ask. There is no maximum. In this question, there cannot be any maximum because the things will go on. Like if you take 34 into 34, 35 into 35, 36 into 36, number will keep increasing. So for example, in this case, this is 24, 89. And then again, if you take 34 into 34, see 1156. This is 1156. So 156. So if we give 24 plant to that person, he can again plant those plants in the equal number of rows and equal number of columns. If we give 89 also, he can do that. If we give 156 also, he can do that. So there is no maximum here. You cannot calculate maximum. Only thing you can calculate is the least. I hope this is clear, Tam. If there is any other doubt, please ask. Okay, we'll move to the next question then. So take 2 minutes to solve this question. The sum of 700 has to be used to give 7 cash prizes to the students of a school for their overall academic performance. If each prize is 20 less than the preceding prize, what is the least value of the prize? So there are 7 prizes, 1, 2, 3, 4, 5, 6, 7. And they're saying each prize is 20 less than the preceding prize. So let's take the first prize as x. This is x minus 20, x minus 40. Fourth is x minus 60. Fifth is x minus 80. Sixth would be x minus 100. Seventh would be x minus 120. So if you add all these prices, the amount of prices, it would sum to 700. This is 1, 2, 3. There are 7 prices. So this will be 7x minus, when you add all this is minus 20, minus 40, 20, 40, 60, 60, 120, 20, 80 is 200, 200, 300, 420. X minus 420 is equal to 700. And 7x is equal to 700 plus 420. This is 1120. X is equal to 1120 by 7. This is 7 1s are 160. So x is 160. So the first price is 160. And they're asking the least price, the least value of the price. The least value would be x minus 120. X is 160, so x minus 120 is equal to 160 minus 120 is equal to 40. Correct answer is option B. I hope this is clear. If you have any doubts, please ask. If it's clear, I'll move to the next question. Okay, I'll move to the next question then. So take x into 120. I mean, yeah, you can do the same. Bhaskar, you can do in that way also. LKR, I didn't understand what is this x120. Bhaskar, you can do that. You can reverse the case and then instead of subtracting it, I can just add that. That can be done. So if you consider x is the least price and then you keep on adding 20 for everything for the next 6 prices, then the value that you calculate here would be the least price. You can do that also. LKR, I didn't understand your question. Okay. So we'll move to the next question then. We'll take 2 minutes to solve this question. Okay. We'll see how to go about this question here. What they're asking is, if 5% fire bullets at a target at an interval of 6, 7, 8, 9, and 12 seconds, there are 5 people. after every 6 seconds and after every 7 seconds, this person, for example, this person fires after every 6 seconds. So the 6th second this person will fire. Next time he'll fire is on 12th second. Next time would be on 18th second. So this is 6, 12, 18 and so on. And the 7th person will again, 7-second guy will also fire at the 7th second, and then 14th second, then 21st second, like this. Similarly 8, 9 and 12 also. And they are saying the number of times they would fire the bullets together at a target in an hour. For example, if to simplify this, if there are only 2 people, for example, if one person is firing it every 2 seconds, another person is firing it every 4 seconds, when will they fire together? So for example, this guy will fire at seconds, 12th second and then 4th second. Then this guy will fire at 4th second and 8th second. And this guy will be like 6th second and 8th second. They'll fire together at 4th second and after that 8th second. So how to calculate this? For that, what we do is we calculate the LCM of these two. The LCM of these two is 4. 2 and 4 is 4. And at the every multiple of 4, for example 4, 8, 12, 16, they'll fire together. So similarly, in this case there are 5 people, 6, 7, 8, 9 and 12 seconds. So what we have to do is we have to calculate the multiple of these 1, 2, 3, 5 numbers, and then when we have that LCM, at every multiple of that LCM, they'll fire together. So for example, I'll calculate the LCM through the factorization method. 6 can be written as 2 into 3. 7 is a prime number. I can directly write 7 here. 8, I can write it as 2 raised to 3. 9, I can write it as 3 raised to 3 square. 12 is 2 square into 3. So the LCM of these 5 numbers is, to calculate the LCM, you have to find the common prime numbers and then choose the one which has the highest power. In this case for 2 raised to 3 into 3 will be 3 square, and then there is no 4, 5, next is 7 itself. The highest power is 7. The LCM would be 2 cube into 3 square into 7. Now they are asking how many times will they fire at the target in an hour. So in 1 hour there will be 60 into 60 seconds. 60 minutes, there is 60 minutes, and in every minute there is 60 seconds. Totally there would be 3600 seconds. So instead of writing 3600 like that, I'll again use the prime factorization method and write 60 as 2 square 3 into 5, and again 2 square 2 cube, sorry, this is 2 square 2 square 2 square into 3 into 5. 2 square is 4, 4 3 is 12, 12 5 is 60. 60 into 60 divided by, I have to divide by the LCM to find out how many multiples of the LCM are there in this seconds, 3600 seconds. The LCM is 2 cube into 3 square into 7. So here you can cancel this 3 and 3, this 3 square and 2 square, and yeah, here 2 raised to 1 would be remaining. So I'd write it as 2 into 5 into 5 divided by 7. This would be 25 to 2 is 50 by 7. This would be equal to 7.1 something. So in this 3600 seconds, the multiple of this thing, the LCM, there would be 7 times when where these 5 people fire together. The correct answer is B. I hope this is clear. Yeah, it is 7.14. But if we just need the integer part here. 7 would be more than enough for us. So I've taken 7. This is, I hope this is clear. If there is any doubt, please ask. Are things clear? If things are clear, I'll take one last problem and I will end the session here. So I hope there is time for one to squeeze in just the last question here. So we'll solve one more question and then we'll end the session today. So please take 2 minutes to solve this question. Time. People who have solved, please post your answers. So there are responses for option B and option A and option C also. We'll see what they're asking and how to go about this. They're saying that if R and S are different integers, so they are different integers, both divisible by 5, then which of the following is not necessarily true? So out of these 4, 3 would be always true. Always true. And one option would sometimes be true. Sometimes be true. So we have to find out which one is not necessarily true. It may be true or it may not be true. So R and S are different integers and both are divisible by 5. So I'll take R as 5n m and S as 5n, where m and n are different integers. They're different integers because they are in the question itself. They're saying R and S are different integers. I'll take the numbers as 5m and 5n, and I'll check for every option here. R minus 5 is divisible by 5. R minus S is equal to 5m minus 5n. I take 5 common, m minus n. Since m minus n is different, they are integers. This r minus 5 has a factor 5 here. So this number r minus 5 will always be divisible by 5. This is always true. So this is always true. So this is not the correct answer. Then r plus 5. So 5m plus 5n. We take 5 common, m plus n. This number is always divisible by 5. But this number is may or may not be divisible by 10. It is divisible by 10 if m plus n is an even number. If m plus n is an even number, then this r plus s is divisible by 10. Or if m plus n is an odd number, for example, if this is 5 and 15, 3 is 9, 5 4 20. 5 and 20, these both are the multiples of 5, but when we add these two, it will become 25. This is not a multiple of 10. So only when m plus n is a multiple of 10, is an even number, will this number r plus s will be a multiple of 10, or at least divisible by 10. So clearly this is not necessarily always true. This can be sometimes true and sometimes wrong. This is the correct option that we are looking for. But we'll see the other options also. We have r into s. We have r into s. We have 5m into 5n. This is 25mn. this number r into 5 is divisible by 5 and is also divisible by 25. So they're saying that r into 5 is divisible by 25. Yes, this is always true because 25 is a factor here. So option C is also true, but we are looking for not necessarily true. This is gone. Then r square plus s square, r square plus s square. This is 5m square, 5 square m square plus 5 square n square. This is equal to 25 m square plus 25 n square. If I take 25 common, it should be m square plus n square. Again, this r square plus s square is a multiple of 25 because clearly we have taken m and n as integers. So r plus s square is a multiple of 25. So if it is a multiple of 25, it will also be divisible by 5. So even this is correct. This will always be true. So option D is also wrong. So the correct answer is option B. I hope this is clear. For people who have got option A and option C, if you have any doubts, you can please ask. Even others, if you have any doubts, you can please ask. Okay. So we'll end the session here. Thanks for coming. We'll take the session tomorrow, continue the session tomorrow. We'll continue with the number properties problem tomorrow also. We'll meet at 8:05 till 10:30. Okay then. Thanks for coming. Good night. We'll meet tomorrow at 8 o'clock. Thank you.